Okay, I'm going to do one final video on a typical A-level question, and this one is a question which basically involves algebra, and it is the simplification of the algebra at the end which causes a problem sometimes. So let's have a look at this. Y equals, I won't make it too difficult, I'll give you a fairly straightforward one. Let's say we've got to differentiate that function there. Now looking at that, what you need to realise is that this is a multiplication of two functions of x. So you've first of all got to spot its product rule. So u is the first function x, and v will be the second function, which is that. We need du by dx for the product rule, which is 1. And we also need dv by dx for the product rule. Now be careful, another step here. To be able to differentiate that, you need to recognise from previous work that we can write that as 2x plus 1 to our power half. And we now need to apply chain rule or function of a function to that. So the power takes priority. Half to the front. Power goes down by 1 to negative a half. Go inside the 2x plus 1 and differentiate, you get 2. And you multiply by the 2. Now simplify this quantity. Notice the half times 2, the 2's cancel, or the half times 2 is 1. So the half and the 2 just disappear. And so this just gives you this answer. And I'm going to write that. The minus sends it to the bottom line of a fraction. Power half is square root 2x plus 1. So there you go, there's dv by dx. So in this particular case, it's a product, so product rule. So dy by dx is u dv by dx plus v du by dx, which is equal to u is x, dv by dx is this quantity. Well, I'll write it in a bracket like so, plus v is this thing here, which I'll write as the square root format because I've got a square root there. So that's v times du by dx is 1. Well, you can put the 1 at the front if you like. Doesn't change anything. Doesn't need to be there. X times the 1 is x over the square root of 2x plus 1 plus the root of 2x plus 1. Now, but basically that's the answer. And if you left it like that, you may well get full marks. But in certain questions, you may need to use that answer to do something else with. And to be able to successfully navigate the second part of the question, you need to be able to simplify this algebra a bit. What I would suggest you do in this particular case is do a little technique which is really useful. What I'm going to do is multiply everything there by the square root of 2x plus 1. Okay, so what I'm going to do is multiply this by the square root of 2x plus 1, the whole thing. So I'm going to say x, and then if you multiply by root of 2x plus 1, that thing on the bottom line just disappears because the two roots would cancel. Plus, and I'm going to multiply that by the root of 2x plus 1 as well. So I'm multiplying everything by the root of 2x plus 1. If you do that, you just get 2x plus 1. Okay, so this technique involves us multiplying every term by root of 2x plus 1. However, if you've done that, patently that answer is not the same as that answer because you've multiplied it by something. So what I'm going to do to make sure that that is the same as that is to put that in a bracket, and I'm going to compensate by dividing by the root of 2x plus 1 outside. In other words, multiply it by 1 over root of 2x plus 1. So let me just say it again. I multiply everything through by the root of 2x plus 1 to get that, and then to compensate outside a bracket, I divide by root of 2x plus 1. So the two effects cancel. So that is the same as that. Why have I done that? Well, because now inside the bracket we've got 3x plus 1 times the 1 is just 3x plus 1. And then we've got the square root on the bottom line. And you end up with a single fraction algebraic term which would be much more easy to use in a follow-up question than this line up here. Some of you may be thinking, well, for this term here, could I try rationalising it, or could I try doing surd work? You could, but in my experience, if you adopt this little technique, people find it tends to work well all the time. So there you go, there's an example of product rule with an awkward bit of algebra involved.